In the dead time compensator section, the user is taught how to develop a dead time compensator such as Smith's Predictor to solve the issue of instability introduced in a system by dead time. In the first step of the challenge, the user has to analyze a step response of a first-order system and extract information such as the gain, time constant, and dead time of the system. By clicking on the step response, these values can be read directly on the graph. Here we can see that the dead time of the system is of 104 seconds, and the gain will be 13.3. To calculate the time constant of the system, we need to know the time at which the system reached 63% of its maximum amplitude. Here we can use a calculator and find out that this amplitude is around 8.36. The time at this amplitude is 5.55 seconds, but we need to subtract the dead time to this time. So this will be around 4.5 seconds. The user then validate his answer and access the next step. In the second step of the challenge, the user must create the model for the Smith predictor. The user has to drag each element in the model area. So this element has the process gain, the time constant, and the dead time. Once these elements are positioned in the right order, the user must validate, and they are linked from left to right. The user is then asked to connect his model to the rest of the diagram. Here we connect the gain after the controller, and we want to get rid of the dead time, so we will select this option. Pressing the result push button will display the results. On the left we can see the system without the predictor. Here we can see the system is totally unstable. And on the right is the system with the predictor created by the user, and we can see the system is stable with a low overshoot. The score is based on the percentage of overshoot of the simulation with the predictor, and this score can be increased by a more accurate analysis of the first order system in the first step. By completing the challenge, the user will have a better understanding of dead time compensators and why they are used to compensate the nefast effect of dead time in a system. They will be able to analyze the first order system from its step response graph and to create their own Smith predictor compensator using the simulation tool.